Assalamu alaikum. In this video we are going to achieve the normality as we have done the detection process in the previous video. Now we are going to achieve the normality of our dependent variable or our errors of the model. For this I am using the same data set as I have done for the previous video. For this the dependent variable is operational self-efficiency and rest of the 4 variables are my independent variable. We need to import this data file into Stata and import the file. Okay, let's start with processing our model. For this the command is rec, select your dependent variable and then select all the independent variables. Press enter. Here you can apply 2 methods for achieving the normality. The first method is transformation method and the second method is change distribution method. You can apply either one of them if both of them applies. Let's say if transform method is not applicable for your data set, then you need to change the distribution of your variable. For this I'll start with the transformation method. Let's start. Transformation method means we need to transform our dependent variable. For this the command is ladder and select your dependent variable. Here you can see the significance against each transformation method. Let's say cubic, square, square root, identity, and then inverse, 1 by square, 1 by cubic, showing the significance. That means we can either change it to transform to one of these methods. But how can we analyze which method is more suitable? For this we need to check the graphical representation of all these transformation methods. The command for this is ladder, select your dependent variable and press enter. You will see a graphical representation of all these transformation methods. We can see by visualizing the graphs that either of them is applicable or not. From this you can see that cubic is not showing normal curve nor the square. The identity is basically the original data set, which is more peaked as we have seen in the previous video, nor the inverse showing the normal curve, and you can see that 1 by square is also not showing normal curve nor the 1 by cubic one. That means all of these transformation methods are not applicable for our data set. However, I'll show you how to transform a variable in case if you need it for your data points. Let's say I need to transform my dependent variable into the cubic transformation. For this you need to make the command which is gen, then rename your variable. Let's say I am renaming it as COSS is equals to, you can copy the formula from here and then paste it, but since the variable name is very long, that's why it is not showing the complete name, so I have to select it from the list and press enter. Here you can see that the new variable have been generated. Likewise you can transform and generate all of these variables one by one and then process again with the transformed variable if one of them applicable for the normality transformation. However, neither of these formulas or these transformation methods are applicable in this case. Therefore, I need to check out for the second method, which is change distribution method. For this, you need to go to SPSS and import the your data set. I'm using SPSS over here because I need to generate the ranks, and this is not this cannot be done on this data. Now the data sheet will be imported in SPSS like this, right? And if you need to rename your variable or either the type, either the decimals, you can go to the variable view and change the type, with decimals, label, whatever you need to change. Okay, let's start with transforming our method, transforming our data. I'll only transform the operational self-sufficiency. For this you need to go to transform, select rank cases and select the variable you need to generate the rank cases for. I need to generate the rank cases for dependent variable. select rank types and select the fractional rank and deselect the rank, right? We need to generate the fractional rank. Click continue and then OK. And you will see in the data sheet that a new variable has been generated, that is RO operation, which is the fractional rank of dependent variable. You need to check the data, and if there is any value that is 1, that means the probability is 1, which should not be, it should not be in the rank cases, and it might be because this was the outlier in the data. So firstly you need to remove the outliers from the data sheet, and then you need to import it. Since I have imported over here, I can replace this value from the previous one, because 1 will create an error while changing the distribution of our variable. Let's change the distribution of our dependent variable. For this you need to go to transform, select compute variable, and let's say I'm renaming it as ROSS. And now what numeric expression you need to select is, go to the function group, select inverse TF, then in function and special variables view you need to select IDF normal. Here you can see that the definition of this command have been generated, where the first one is the probability. Probability is your fractional rank. Then you need to add the mean and standard deviation of the this variable, right? So in first question mark or first rank we need to select the fractional rank, right? Then we need to add the mean. You can either analyze the mean in your SPSS, but I am doing it over stata. For this the command is summarize, select your dependent variable. Here the mean, standard deviation, minimum, maximum have been generated. I'll just copy the mean from here and paste it in the command section in the middle. Then you need to add the standard deviation. And then you need to select OK. Here you can see that it is now not showing the error one. If we haven't changed the 1, it will show the error, right? So I have changed it. That means it easily computed our new variable, that is ROSS, a new variable, a new normalized dependent variable. You can check the normality by go to analyze, descriptive statistics, explore, select the variable you need to check. I am selecting our change distribution variable. Go to statistics. I need descriptives, select continue. I need plots, histogram, let's say, and continue. And we don't need to select any other options from here. And display both the statistics and plots, that's why I have selected both, and click OK. Here you will see the normality test histogram, and you can see a very clear normalized histogram have been generated from this distribution. And from the tests that will be shown over here. Okay, you can see that the mean and standard error has also been changed. Minimum, maximum value will also change because the arch distribution have been changed, and now you can see that this distribution is showing the normality. We can copy this and paste it in the data file to check through tests we have done in the previous video, right? I'll show you with the test. Let's say I'm doing it with SWILK test. You can see that it is greater than 5%, which means our data is normal. You can also apply all the tests which we have done in previous video. I'm just showing it you with the one test because all the tests will now show the same result. That's it. this is how we can achieve the normality of our data set. It is very important to achieve the normality before processing your data, because if you're not achieving the normality, then your results will not be correct, and it will not show the true picture of your model. So it is very important to achieve the normality in the first place. You can either achieve the normality of your dependent variable or your errors or your independent variables as well. It is upon your choice. So that's it from this video. Thank you so much. Allah Hafiz.